Let's take a look at the last two questions in your review packet. Just another example of a proportion and a mean confidence interval. So number 5 here says the retailers report that the use of sent-off coupons is actually increasing. The Scripps Howard News Service reported the proportion of all households that use a coupon is 0.77. Suppose that this estimate was based on a random sample of 800 households. Construct a 95% confidence interval for P, the true proportion of all households that use coupons. Okay? So again, we're going to do state, plan, do, conclude. So we want to find a 95% confidence interval for the true proportion of all households that use coupons. So yep, I'm just stating it right from here. I go to the problem and use the context right with what it's given to me. So we will construct a one sample, since we're dealing with a proportion, Z confidence interval for a population proportion P. So now, random, normal, independent. Random. Yes. A simple random sample of 800 households was taken. Normal. I need to check. Is n times p hat greater than or equal to 10, and n times 1 minus p hat greater than or equal to 10. Well, you have 800 households, 77% which are using the coupons. So 800 times 0.77, 616. So if 616 are using the coupons, 800 minus 616, if I go 800 times 0.23, I know that's going to be, let's see, 184, since these two numbers have to add up to 100. Or not 100, sorry, 800. So yes, our sampling distribution is approximately normal. All right, do the independent. Okay, so I need to check. Is the population greater than 10 times my sample? So is the population greater than 8,000? We're going to say yes. We will assume there are 8,000 households in the population. All right, so now we get to calculate out the interval. P hat plus or minus Z star times the square root of P hat 1 minus P hat over N. So my P hat was 0.77. Z star, 1.960, we're doing 95% again. Square root, 0.77 times 0.23 divided by my sample size, 800. So 0.77 plus or minus 1.96. Whoops, I like to always do this square root part. 0.7, well, I did take a decimal, Mr. Parks. 0.77 times 0.23 divided by 800. Then times that by 1.96. So 0.029. So now if I add and subtract that, 0.77 minus 0.029, so 0.741, and then if I add it, 0.799, I believe, if I add that correctly. Okay. So our conclusion, we always say we are blank percent confident, 95% confident that the interval from blank to blank, from 0.741 to 0.799 captures what? Context of the problem. The true proportion of all households that use the cent off coupons. Whew. All right, one last problem. So let's flip over to number 6. So it says you randomly select 36 coffee shops around the metro and measure the temperature of the coffees sold at each. The sample mean temperature is 162 degrees Fahrenheit with a sample standard deviation of 10 degrees Fahrenheit. Find a 99% confidence interval for the mean temperature of coffee sold in the coffee shops around the metro. Ooh. Notice how it says mean, so 99% confidence interval. Yay, finally something that's not 95. All right, so state plan do conclude. We want to find a 99% confidence interval for the true mean temperature of coffee sold in coffee shops around the metro. Woo. All right. So we will construct a one sample T confidence interval for a mean. So, is it random? Yes. A simple random sample of 36 coffee shops were taken. Normal. Okay. So now, n in this case equals 36. This is greater than or equal to 30. So according to the central limit theorem, our sampling distribution is approximately normal. Sorry, I'm starting to abbreviate here. As you can tell, I'm even getting tired writing these a little bit. All right, independent. So yeah, we are sampling without replacement, so we need to check, is the population greater than 10 times 36? So is our population greater than 360? So we will assume, sorry, that's such a bad I. There are at least 360 coffee shops in this metro area. That would be kind of interesting to know. If we talked about the whole Twin Cities, St. Paul, and the 7-county metro, is there 360 coffee shops? That would be interesting to find out. If you're bored, see how many Starbucks and Caribous there are just in Minnesota. See if it actually is up at that level. Be kind of interesting. All right, so now the interval, sample mean plus or minus t star, sample standard deviation over the square root of n. So now up at the top, they actually give you these values. So the average was 160 true. The standard deviation was 10. Our n was 36. So to get t star, I'm going to go, hopefully I'll write this right this time, inverse t, okay? It's a 99, so I have to go 0.995. Remember, I have to include that little tail. It's everything to the left, okay? And then my degrees of freedom here is 35. So second vars, if I go inverse t, 0.995, okay, 35. Go ahead and paste that in there. Go ahead and hit enter. All right, so I get a t star score of 2.724. Now, if you actually use the table, you don't have a degrees of freedom of 35. So you could use the conservative. It's okay if you use t star in this problem to be 2.750 also. If you use the conservative estimate, okay, they will accept both. I'm going to use this one right here. So my mean, 162 plus or minus 2.724 times the standard deviation, 10, divided by the square root of 35. So I get 162 plus or minus, so 2.724 times 10 divided by the square root of 35. So I'm hoping I'm entering that all in there. So I'm getting a plus or minus about 4.604. I'm just going to go 0.460 since it'll keep it nice degree-wise. So 162 minus 4.6, 157.4 to 166.6. Okay? So our last conclusion in this review, we are what? In this case, 90. Oh, I did 99, didn't I? Oh, dang it. Was this a 99? Oh, it was a 99. Never mind. I did that right. I thought it was a 95 for a second. We are 99% confident, okay, that the interval from 157.4 degrees to 166.6 degrees captures the true mean temperature of coffee sold in coffee shops around the metro. All right. Hopefully you enjoyed both those videos or both those good luck with your test.